Welcome to the 2023 Newton IoT Security Technology Global Forum. I am Robert Lin, Senior Technology Manager from Newton. Newton was established in 2008 to bring innovative solutions to the semiconductor industry. We continue to make global investments in R&D, business, marketing, and supply chain logistics. We also do our best to support current and future customers and contribute to the realization of a secure, safe, and intelligent human life. As the AI, machine learning, and IoT era coming, we are convinced that security function is no longer to be an option to IoT devices from now on. This year, we are honored to invite our valuable business customers and partners in technology who have accumulated decades of expertise in the industry where they exist to share leading IoT security successful stories, latest trends, and valuable ecosystem knowledge with us. Taking a deeper look into agenda sections, which covers the smart grid relevant security knowledge, ultra-low power Wi-Fi BT dual band dual mode connectivity solution together with the M2354 series, building automation security and a new IoT business model with data security considerations illustrated by a personal security device with fingerprint sensor and the numerical family. We are confident all attendees will receive useful information in building and expanding IoT application products based on real business cases and insights for future requirements of IoT security. All participants will be given a buy 100 get 30 off voucher code for Newton Direct eStore at the end of the live event. So be sure to stick to the end. Among all post-event survey respondents, we are giving away 50 plus sets of NewMaker M235X series evaluation boards. So don't forget, submit feedback and take the chance to try out our product. Ladies and gentlemen, let's start the forum now. Firstly, let's welcome the first section provided by Dongsun Huang, Senior Sales Vice President from SPI Korea.
Hello, everyone. This is Dongsun Huang. I'm responsible for global business development in security platform company. Thanks for having me to present the case study on 2023 Newton IoT Security Technology Global Forum. We will begin this session by discussing a little about what is the cybersecurity smart meter project worldwide, how big is the market and the demand. Next, we will move further on the history of the hacking and the security, then talk about what is the challenges and why we need a network security. Moving on, we will discuss the detail of the case study. Then I'm a little bit share with the history of our partnership with Newton, explain how we work together and go through all those challenges. And finally, we will end this session by product and company introduction. The smart grid is more than just the power generation and distribution. It can be an ecosystem of IoT connected technologies and communication network. And smart meter plays a key role in this smart grid infrastructure and represent a growth market globally that is predicted to grow to $44 billion by 2026. There is an increased demand for minimizing negative environmental impact and for conserving energy. Smart connected meters can also enhance capability to reduce cost and waste. Today, the smart metering devices are enhancing safety and preventing fault, having more integrated components. Data connectivity and sophisticated software connected to metering devices can help increase operator and consumer safety. Global smart meter installation investment reached to $18 billion soon. Now, we need to understand what is the cybersecurity in this industry. As you know, cybersecurity is the set of a practice used to protect the computer, server, mobile devices, various electronic systems, and the communication computer networks, especially today. We're going to talking about more IoT devices from malicious attacks and threats. Let us now look into the history of the hacking and security, the timeline of hacking. And then security started in 1962 with the first Troll attack. The early stage of the cybersecurity in this industry to manipulate devices by third-party manufacturer employee. It happened in South America, 2009. In 2012, 2017, there were several data breaches on bigger service provider servers conducted by the authorized third party. In 2017, there was a ransomware attack, and in Europe, hackers attacked the PLC system to get private key. It's known as Bluebone Vulnerability Smart Meter. In 2019, DDoS attack is caused some services to completely shut down for a few days. We have seen till now these cyber attacks and threats comes in all types and sizes, impact various sectors. The growing cyber attacks cost the world economy more than $1 trillion. It is almost 1% of the global GDP. According to Global Bain & Company report to say that the global AMI cyber attack estimated total IoT security market size up to $41 billion. Now you understand how important smart meter as the key role of the ecosystem of the smart grid infrastructure and how critical the cyber attacks in this industry. This slide explains that what is the challenges to implement this the security, and then I will continue to talking about what is the solution to solve the problems. The first challenges are long business cycle. It doesn't require the long development time and effort from the hardware layer to software layer. Demand of the security just start boot up the devices, run the software. The technology rely on hardware core design and chip design require in very limited resources. The development cost and integration fee also very high. Single dollar increase is very significant to the low cost IoT device market. The second challenge is the security regulation. At the beginning of the IoT device security implementation, there are no strong enforcement regulation and guidance of security. It makes the client to hesitate to adopt security solution. But biggest challenges is no security expert in the device manufacturer. Most of IoT hardware device manufacturer has no resource to implement the security on the device to meet the service provider's security requirement. Okay, let's talking about case study. I'm gonna share with you guys one big project we quite success with Nuvoton is Capco Smart Meter 2.0 project. Capco is the only electricity power supply in Korea. Capco's year revenue reached to 60 billion US dollar. It's the top 5 in the worldwide. Capco installed the 35 million smart meter over the country. The project is replacement of old smart meter to advance the security smart meter. It's a 7 years the plan, and the pilot project started from last year. The project, what is the key to success is provide the certified technology and high assurance security functions for devices. And most important part is the cost effective hardware design. This slide helps you to understand the project history. The project has developed by AMI standard requirement from version 1.0 to 2.0. AMI 1.0 is quite simple. It's a require remote metering system only. And 2020 and 2021, Capco started to concern the security. The smart meter required a few security functions like data encryptions, key management, used to secure element hardware to protect the private key. And also the 1.5 standard need to support the diverse communication net protocol like CAN, RS485, and YSUN. And 2022, Capco released the AMI 2.0 standard. Security enhancement is very significant in this version. Hardware devices to meet enhance the security function like a secure boot and secure update and attestations. Also need to support the wireless network connectivity like LTE Cat M1. The hardware design also changed to unified model, like metering and modem together is one box. In next slide, I will explain the detail of the security requirement. This is a smart meter network diagram. There are client and server and AP. Three different layers need to have a different security technologies to protect end-to-end communications. Mostly important of security function in the client is a secure boot. Whenever the boot of the devices, you must be guarantee it is a safety. TLS protect data communication from client to server. Finally, you allow only authorized user and data to access to server. SPI trusts the SDK with Nuvoton technology solved a few challenges is what smart meter manufacturer faced. The SDK made of 3 parts, include the hardware and software and certificate. Hardware, we provided the sample testing board to client. It meets the Capco's hardware design requirement. This allows smart meter manufacturer easy to understand how to build the security enhancement smart meter. Our manufacturer client saved almost 6 months to 1 year's development time and effort from this testing board. Software. We provide the ARM Trustzone-based trust platform, allow client to choose different function of the security to meet different service provider demand. Finally is the certificate. SBI Smart Meter got an ARM PSA certified 2018. It's the first OEM certificated PSA. And 2022, we passed Korea government crypto module validator program. It means that IoT device manufacturer doesn't need to use secure element chip additionally anymore for TAPCO project. Only one chip can do multiple works based on the secure and not secure zone in the chip. It also allows device manufacturers to save the cost a lot. And 2023, this year we got a fifth certificate for global market. Here are the few our benefit of this solution. The first, our solution is a high assurance end-to-end security solution for AMI market. Our solution cover the full function of the requirement of security for secure data devices and the data and communication. And also, it is an embedded hardware integrated security solution. The main is that our solution is provide a very high performance, high level of the security. The second benefit is that our certified solution applicable the industry standard solution. We meet the industry regulation. We pass the validation program for global users. And our solution also to meet the industry standard network and telecommunication infrastructure too. The last benefit, the most important benefit is that our solution allows the client easy to use. The platform and service to help apply the standards and service process of AMI requirement to client infrastructure. And also, this one chip solution is very valued pricing strategy to help adapt the solution to client different step of the AMI services without any cost risk. Here is our solution architecture. Today, I'm not going to explain a very detailed technology, but you can easily find it. Our solution architecture is based on a KCMVP certified module. And then we isolate non-secure and secure zone and data and application. And we connect diverse the network module. This page is, I will a little bit introduce our product from 2019 to last year. We worked with Newton very closely from the 2019. We made a first smart meter AMI 1.5 standard, the sample smart meter devices. It is include Nuvoton M23 15 MCU series, and also is designed for the secure element additionally. In 2021, we also made the modem for smart meter market. And 2022, we finally designed with the security smart meter that meet this AMI 2.0. It's an Amigo project. It's the Capco's next generation security AMI smart meter project. We work with customized Nuvoton MCU M2354, and also it is a certified the module inside. So only one chip to meet the different type of the security solutions. So it saved a lot of the cost of the security. Finally, I a little bit share with you guys our company. Our company started 2015. The most of management R&D research from Samsung Electronics Security Group. We faced so many issues of IoT devices, security issues. So we have a vision at that time. In the future, the IoT market is fast to grow, and then security is very significant the threat of the market. So we started to develop IoT-based, device-based solution. You can see the slide. We have a many partnership with diverse chip vendors like STMicro, Nuvoton's, and ARM microchips. And also we have many of the project work with telecommunications for IoT businesses. 2020, we have a significant investment and expand our business model to very critical IoT device market like a smart meter and CCTV camera, and then WordPad, the VPN market. And we got so many great certificates from Korea and global market. Let me introduce our teams. We are a few top management and an R&D head, average 15 years security and system development experiences and global business experience. And also we have a major shareholder like the SoftBank premier partner to support our company to grow. And finally, let me very quickly go through what is our application and target application market and solutions. The first is the AMI 2.0 market. We provide the secure smart meter and modem card. And another biggest market is like a surveillance, so home automations. And also we have digital payment solution for post-market. Line payment devices, we actually used our technology to protect to user data protection. And also we have IoT portal support. We work with SK Telecommunications. We provide the diverse, the LTE IoT networks solution. And also we have a secure sensor and IoT device for train. This is all about today's session. If you have any question, just let me know. Thank you so much for today's presentation.
Thank you, Dongsun's good speech and the fruitful knowledge sharing with us. Now let's welcome Fred Lin, who is CEO from SunASIC Technology Taiwan. He will bring a speech of IoT business model and Littleton processors.
Hi, everyone. My name is Frederick Lin, the President and Technology Officer of SunASIC Technology. Today, we're going to talk about the IoT business model and the Littleton processors. We know everything started with a big event that in 2016, SoftBank Corporation acquired ARM with $32 billion. ARM is a leader of a mobile architecture and targeting the future IoT growth market. I think this was why that Mr. Sun see the potential of the IoT market and made the decision. And after a couple of years, we know the IoT market was not growing as fast as we expected. And the reason is that the IoT is a highly diverse market. It's not like the personal cellular phone or notebook computing, server computing, that you make a product design and sells tons of millions of them. And the large organization we see like the Google, like Amazon, like Ali, and they have built the top infrastructure, but they don't have the killer application like the cellular phone that you can sell many of them and to justify their huge investment. And the small market, small organizations, small companies, they don't have enough resource to tag the connectivity, the security, and the complexity of combined hardware and software and their specific knowledge towards the application. It's very difficult to have all the talents all put together in a small organization to address the market. So we see a big gap between these companies as everybody is struggling to find the sweet spot or position in the market. So we've seen the large IoT infrastructures built, the Ali, the AWS and the Google Cloud and Apple Cloud, all the services there, but we don't see that many applications using the services. And we believe that from our past experience with personal security, that we see the trust zone architecture is the key to the success of IoT market, because the protecting the software IP is as important as protecting user data and protecting the data transportation. The model we see with the trust zone architecture is a model we call the incremental firmware development that allows the people to build application on stacks of tools and services from other vendors. And we provide through the infrastructure, we provide the customer with a customized microprocessor with the software architecture and software IPs loaded to address their need. And how we can do it? We believe that the IoT market can be addressed more efficiently in the same way we built our personal security supporting network and to address the personal security market. We were actually the first vendor to deliver the demonstration system in 2017 in German. In the trade show, we were invited by ARM to demonstrate the fingerprint application. We ported it to the Cortex M23 processor. At that time, we jointly with Nuvoton to demonstrate the new powerful, although very small platform to address the personal security market. Our strategy to address the IoT and personal security market is a pyramid. When we look at the pyramid, we see the biggest part is the bottom, that all the application developer is writing their software, designing their hardware for the IoT market. And the top of the pyramid, we see the cloud players like Google, Microsoft, Amazon, and Ali. They provide their cloud service for the transportation and the data management of IoT. And all these small applications we see that rely on the very big population of a developer to do their work. And we see the middle-sized companies doing their own vertical system from cloud to terminal devices, and they maintain a high-cost oriented solution for the IoT market. But this is not what we see for the future. So we see for the future, we need to support the mass population of all the kinds of developers. And the use of portable security devices like this. Everybody has a cellular phone. Then we use the cellular phone to save our personal data. We use the cellular phone to do the shopping. We do the cellular phone for the banking, then personal security management. But it's more like the high cost equipment. Everybody don't have a multiple cellular phone, and it's quite expensive to replace one with every other years, and you have to transfer data from one to another. And we look at the personal security market as a much more smaller scale, that a device that address the specific need for, let's say, like a banking, like web browsing, like operating the car, or opening the door and keep track of your personal data. And we see a more portable device and the low-cost device for the market. And to address this market, we use the trust zone architecture. With the architecture, we have the trusted code and data, and the non-trusted application code that provided by third party. And when we look at the architecture, we look at the collaboration of all the different players, and like software vendors come up with their package, like Java, fingerprint security, AWS, the cloud service, embedded the operating system, and storage management, wireless, and some specific solution that provided the third-party company to the developer. And in the trust code data area, we also keep track of security data like biometric information, like a password, like a crypto keys, and for the user. And on top of this common architecture, we allow the application developer to put their own software and the data management on top to build their own product, like padlock, like a remote control, like USB token. Okay, this is the architecture we use to address the personal security market. And we believe based on the same architecture, we can develop an architecture and ecosystem for IoT world with ARM and Nuvoton, of course. And our vision for the future market is like this, that all the application developer is facing a same interface as for example, a e-store, that with the e-store, they can purchase the hardware platform, they can purchase the software IP, and they can purchase the design services, and they can purchase engineering support that allows them to put together quickly their solution. And we even provide the manufacturing service to the application developers to allow them to quickly build the application and send it to the market. And the application can be all kinds, like from personal security to remote control, like remote monitoring, the IoT applications. So this is the market we look at that helps the application developers to address the IoT requirements that in the bottom of the pyramid. And this incremental formal development scheme, when we look closer, this is a development model we propose with the Nuvoton. On the bottom, we have the Cortex M23 and 33 trust zone architecture. And on top of the stack, we provide the software IP and the library that allows the application developer to manage the user data, and providing them additional possibility to integrate third-party IP in the system, and that they have only need to build their own simple layer of software on top, and their product is ready to go. So all these are developed incremental towards the final product in a very cost-effective way. When we look at this model, we see the advantage of this development model is 3 parts. For the software vendor, IP provider, we provide a safe and trackable code distribution method. And we help them to expand their business opportunity through the e-store that allows them to address small customers as well as the big ones more efficiently. And we have simplified their customer support efforts through the same interface. And for application product developers, we provide we call the one-stop shared shopping experience that save their NRE costs, and they can buy hardware, software, IP all once in the e-store, and that lowers their coding cost, testing cost, and make their development cycle very quick. And even we provide the manufacturing and assembly services. And on top of this, we provide a shared resource among developers and software vendors that we provide certified security and connectivity library, and we provide standardization of APIs, and we provide the open source project to help the developers. And give an example of our personal security applications, and the same platform or same fundamental part of the software. We see the secure platform. On top, we have a secured operating system. We have all kinds of tools and drivers provided to the application developers, and the application developers put on top of their own application the software stack we provide to them. And link, like with the example of personal security, we provide like the solution for the FIDO keys, like the padlock, the door lock, for the banking applications, for the remote control type of applications. And when we look at the IoT infrastructure, the same model can be applied to all the terminal devices, that each terminal device having the same similar architecture, that with the operating system and the secure platform on the bottom, and all kinds of IP and the tools and APIs provided on top of it, and the application provider, application developer put their own effort on top of all the stack. Just like you buy a personal computer, you have all the operating system and the web browser and the Office installed, and you just need to put your own stuff on top and ready to go. And to establish all these, we need to have the technology element to address the need, including the low-cost hardware, and like the Nuvoton M23 and M33 solutions. And we have the secured execution environment. We have the crypto engine to ensure the safety of data and the communication. We allow the easy to implement the access management and the connectivity, low power, and the simple application interfaces through standardization, and the collaborative model that allows the different software vendors to put their effort in the same platform quickly. And we can build the platform to the customer's specification. And on the bottom of this, the technology element from the ARM and the Nuvoton are trust zone and XOM, execution-only memory, that we use to protect the software code, as well as the user data, that helping the software developer to secure their income without worrying that to release their library to the public. And Nuvoton also provides a flash lock that allows you to protect the software and the data in the system. And they provide also the JTAG ICP interface to ensure the ease of development under the secure platform and secure environment. And with the Nuvoton platform, we provide two major class of personal security product. One is a small, what we call small fingerprint module, or we call the smart button, and with the security built in. And another type of class of devices is the USB dongle and that allows people to put various security function to it. For example, the same USB token, we can use it to keep crypto keys, certificate, data, and password. And with the smart fingerprint button, we can build a mouse, padlock, door lock, the personal security equipment all over the places. And when we look at the supplying network that allows us to support the application developers, we see the e-store in front, and the R&D team supporting the tools and the software, and the production facility that allows the quickly integration of everything. And the supply chain management allows us to provide the IP and also the contract design manufacturing service. The IoT business network will allow us to expand an IP offering from personal to business security with all kinds of RTOS and the tools and OTA services and the remote installation and the management. And we address the market like personal security, smart home, industrial, environmental, agricultural, public utility, and so on. The customer segment, we look at the IoT is automotive is a major part, and public service, including utility and surveillance, and smart home, smart appliance, and smart community services. Our value position to the market is secured IoT networking, cloud awareness, and hardware and software integration services. And we provide the value through our key activities like software standardization and training, evaluation boards, distribution and support, and module marketing, and through smart packaging. And our key partners include key PCB manufacturing, packaging house, software developers, and programming and testing service providers, and with the sales and marketing team support, engineering team support, and our patent suite. And our customer relationship allows us to maintain the ecosystem and the design and production services included. And we help the customer to market the product through cloud partners and cyber media and the e-store. The cost structure is mainly on R&D, sales, marketing, and contract production with our patent suite that allows to ensure the revenue stream for ourselves and the customer. And the revenue stream comes from personal security product, IoT security modules, and the NRE-based contract design and development to share the resource and profit with our customer. We have about over 30 patents that allows us to address the IoT security market, including what we call a secure IP transfer mechanism through the network. And we also have a scheme that allows to various functionality to build into a simple device with a multiple fingerprint to control the function. And we also have a very interesting service based on a patent that allows the user to manage an IoT device, managing all kinds of simple device through a unified interface, a web browser. Our core competence towards the IoT market is the fingerprint sensor offered in industry, including many image quality, low power, and reliability. And we have innovative packaging technology and secure IP license transport technology. And our patent portfolio ensures the net profit stream for ourselves and our customer. And we provide a series of pink fingerprint sensor. That's our core business from small to large size, which addresses the personal need and towards the governmental, like the airport, the police station, to manage the fingerprint for large population. And so on top of this core technology, we hope to will help the IoT customer to develop their technology and address the market need. Thank you very much.
Thanks, Fred. That's excellent speech. Now let's enter next section. Peace of mind for IoT embedded designers. A secure end-to-end reference design. The speaker is Ali Sebat, CEO of Septronics Business Group.
Hello, my name is Ali Sebat with the Septronics Business Group. I have been working in a consulting capacity with Nuvoton with the goal of developing an end-to-end secure solution for embedded applications targeted at building automation systems and other applications like building automation systems. Today's presentation is focused on delivering peace of mind for IoT embedded designers based on a new secure end-to-end reference design that we have developed along with Nuvoton and our ecosystem partners that can be used by embedded designers and Nuvoton customers to achieve end-to-end security. IoT and security are a very hot topic these days. And of course, we know embedded designers are experts in what I'm calling operation technology or OT. Embedded designers are excellent at designing safety machines or safety applications, controlling sensors, controlling actuators, devising very sophisticated power management schemes for embedded machines, as well as designing machines that can operate for very long periods of time with various power management modes. With the proliferation of IoT, however, these connected machines and their operation technology functionality are creating vulnerability for IT infrastructures. And let me talk about that. You see, embedded designers and the embedded machines that they develop support various infrastructures. In this case, a building infrastructure is supported by an HVAC machine, security cameras, elevators. Of course, there's motor control and connectivity in elevators, parking control, fire and safety equipment, thermostats, and environmental control, UI machines, access control. And all of these embedded machines that support infrastructures, whether it's a university campus or a hotel or a commercial building or an apartment building, retail, these equipment are referred to as operation technology. And unfortunately, they have become the #1 target of cybersecurity hacks and hackers because, typically speaking, they don't have much in terms of security. And this is the essence of today's presentation and how this Nuvoton reference design and solution is going to address this vulnerability. There are thousands of vulnerabilities every month. I'm going to share with you two highly visible examples that have been in the news over the past decade, although there are thousands of them. One, back in 2013, a famous and big department store was hacked through a mechanical contractor that this big department store had hired to manage some of their equipment, such as their HVAC system. And hackers were able to detect a vulnerability in this third-party contractor's credentials, and they're able to hack into the IT infrastructure of the department store and steal literally millions of customer credit card information. And as a result, there was a huge financial liability for this department store. In 2018, there was a casino lobby connected fish tank thermometer that was hacked, where hackers were sitting in a casino lobby and they were able to hack into the thermometer that was in this magnificent fish tank. And this thermometer was connected, obviously, to the IT infrastructure of the casino. And by hacking the thermometer, which lacked adequate security credentials and security protection, they were able to get into the IT infrastructure and steal droves of customer information. In fact, when we look at psacertified.org, This is an organization that has that's primary goal is to devise schemes for IoT hardware, software, and devices to provide security solutions and security schemes. When you look at their website, they claim that on average, there are 5,400 attacks per month on IoT devices, with 7 million data records compromised daily. And they further quantify these attacks to amount to 330,000, or the average cost of an attack is over 330,000. And the future, the cybercrime damage by 2010-25 is going to be just staggering. So as embedded designers, developing machines, OT machines that are connected to infrastructures, we have to take into consideration these challenges. So when we look at IoT and security, unfortunately, some embedded designers believe that because their machines have never been hacked, then their systems work just fine. But this is like driving a car without insurance. Of course, you're fine until you get into an accident. Some embedded designers rely on the security of the transport layer. Once the data or the intelligence from the machine is transferred over cellular or Wi-Fi, then indeed the transport layer provides security, but that's after the data has left the machine. The challenge or the problem is when the machine is collecting the data and deriving intelligence from that data. So the opportunity is to secure the data and the intelligence at the machine or the device level before it's sent out. And if we do so, this will protect everyone in the value chain. As I mentioned, in the case of the department store that was hacked, the third-party contractor also felt the pain of this massive cybersecurity attack. So by securing embedded machines, we not only protect ourselves, but also protect our clients and everybody in the value chain. We know infrastructures, as I mentioned, it could be hotels, university campuses, commercial buildings, retail stores, shopping centers. They're adopting IoT at a rapid pace. IoT helps with energy savings. IoT helps with being efficient in terms of space utility, in terms of many cost savings and many other benefits. So IoT is here and growing at a very rapid pace. And when we look at this diagram, typically embedded designers have sensors spread all over, and they take advantage of the sensor data, whether it's motion sensor, environmental sensor, air quality sensor. And the data from these sensors is turned into some form of intelligence via the HVAC machine or the energy equipment or the elevator, and that intelligence is transmitted into the IP network and the IT infrastructure of the building. The barrier to entry has been this fuzzy environment, or this rather barrier between the OT domain and IT domain, meaning embedded designers build these machines that do a phenomenal job in the operation technology domain, but properly connecting them and ensuring secure connection through the life of the device and the connectivity to the infrastructure is the challenge and the barrier to entry. In fact, when we look at these two domains, the IT and OT domains are typically integrated at the cloud level using various cloud applications. So with that, what has become known in the industry as this integration of the IT and OT domains is referred to as a device lifecycle management, also known as DLM. And there are typically 5 steps on average with device lifecycle management. The first is onboarding, where the cloud infrastructure of a building or any entity would first properly onboard an embedded machine that's going to be connected to that infrastructure, that is going to perform some operation technology work. Let's consider a new HVAC system or a new thermometer that's going to be attached to a building. So the first thing to do is to properly onboard that machine with the proper credentials. The second is to configure that machine and control that machine to work in the way it's intended to work in its environment. The third step of DLM is to monitor the machine on an ongoing basis, probably send alerts or monitor for diagnostics information, so if a machine needs repair or maintenance. And the fourth step is to perform that maintenance, and in many cases, it means over-the-air software and firmware updates. And finally, When the machine has done its job or reached its end of life, or if it has been compromised, the infrastructure, the IT infrastructure wants the capability to be able to decommission or sunset or kill that machine in case it's been compromised and hacked. So these are the 5 steps. In fact, I'll use a consumer example to talk about these steps. Nowadays, when you buy an exercise machine, most exercise machines are connected to the cloud, and they come with some subscription model, a monthly subscription model for the type of classes that you're interested in enrolling in. So when you first buy the exercise machine and connect it, to the cloud, if you will, the first thing the cloud infrastructure, or the company that sold this bike machine, is going to do is onboard the bike and make sure it's a legitimate bike, make sure it's one they have sold, and then they will configure it for the type of, let's say, monthly subscription model or classes that the customer or consumer has signed up to pay for. So that's very important, so that the bike will only function in the manner that it's being paid for. Of course, on an ongoing basis, there are sensors on the bike that monitor its performance. And if they sense the bike is not performing well or needs to be maintained, those alerts will go to the consumer. And then from time to time, they might want to send software updates because of security updates or functional updates. And of course, finally, if the customer doesn't pay their subscription, they might want to end its functionality, decommission it, if you will. When we look at the IoT infrastructure I was referring to earlier, the building infrastructure, for example, Nuvoton has devised a secure end-to-end IoT reference design to really make these onboarding steps, or these DLM, device lifecycle management steps, very easy for embedded designers. You see, many companies that develop embedded machines, as I mentioned earlier, are excellent at controlling actuators or reading sensor information, but they don't necessarily have the resources or the expertise to do security, to connect to the cloud in a secure manner, to exchange keys, to encrypt the keys, and to ensure a proper method whereby the user of these machines can interact with these machines in a secure manner. So this reference design is intended essentially to simplify this secure provisioning. So those DLM steps, or provisioning an embedded machine, is very complex, and this reference design's intent is to simplify the provisioning of embedded machines. What you see on the left are the different components of the reference design, and I'm going to go through them one by one and explain what they are, and then go through the functionality of this reference design. So let's first talk about the components. First and foremost, Nuvoton partnered with a global IDH ecosystem partner called DonorWorks, located in Michigan, United States, or Grand Rapids, Michigan. And they are an excellent independent design house with a very wide spectrum of engineering skills, all the way from complete device to cloud development, secure embedded technologies. They develop FDA solutions, and of course, experts in FPGA. So Nuvoton partnered with DonorWorks to develop this reference design. And at the core of this reference design is the Nuvoton NuMicro M2354 secure MCU, which is rich with security features, including it has the ARM trust zone, it has key store, and of course a cryptographic hardware accelerator to help with encryption of the data and the keys. Next, we're using the NuMaker IoT M2354 board. It's a very all-encompassing, it's an IoT board with lots of great features. It has in it, of course, on it the M2354 secure MCU, an environmental sensor, a LoRaWAN solution using a Semtech radio. It offers Wi-Fi via an ESP module, Bluetooth, and of course, Nuvoton's NuLink onboard debugger. Next, we have developed a mobile app for provisioning. This mobile app is available both on iOS and Android stores. It's used initially for onboarding of the machine, as well as authorized installers and users. So when you're installing an HVAC machine or a thermostat or any consumer gadget like the exercise bike, so this reference design, while its intended initial use is building automation systems, it's developed in such a way that embedded designers can use it for a variety of applications, not just building automation. So onboarding, this app is used for onboarding of the machine as well as authorized installers. A lot of times it's the installers or the users that misuse or don't properly use machines, and these machines become easily hacked. Of course, it enables provisioning of the devices to the cloud and some device management functionality. For this specific reference design, we are using a Tectelic LoRaWAN gateway. Of course, it has integrated cellular solutions and Ethernet backhaul, and it provides various frequency bands for various geographic regions around the world. And for cloud, where the keys, the key management, and the cloud type of applications, we're using AWS IoT Core for LoRaWAN, as well as AWS Cognito for establishing users and user management. Finally, there's the mobile app is also used to display sensor data, again, both on iOS and Android stores. And in this case, because the IoT board that we're using from Nuvoton uses an onboard environmental sensor, we can measure and display temperature, humidity, and pressure information. So let's now unbox this. And one of the first objectives that we focused on was to provide a really an excellent out-of-box experience for designers who receive this reference design. We wanted to make it very easy in terms of setting it up, because the objective is to enable designers to focus on their application and not really focus on provisioning and security and connectivity. So I am going to take you through the steps that provision and connect any machine that you want to design to the cloud, and you'll see how easy we have made this. So let's go through the out-of-box experience. First and foremost, when you power up the machine, the reference design in this case, the device will come up in BLE broadcast mode, and you'll use the app to scan for the device. Next, the app will connect to the device. And then on the app, you'll select the type of provisioning keys that you want to get from the cloud server. Once you have selected the type of keys you want, you make the request. So the app will make key requests from both the network server as well as the application server. Then the servers will generate the provisioning keys. Once the keys have been generated, then the application server will link the device to the user's account. This is very important. If you remember, I talked about installers and talked about users. So if you want your embedded machine to provide the level of security where you can ensure the right user is using the machine or the right installer is installing the machine, then at this stage, this is where the application server is linking the device to the user's account. Then the server will send the provisioning keys back to the mobile app. And of course, at this point, the app will transfer the provisioning keys over BLE to the device itself. So what we've done right now is we have used the app to request the provisioning keys from the cloud server. The cloud server has in turn generated those keys, linked them to the user, and sent them back to the app. And then the app basically will transfer these keys to the device. Now, the device, the first thing it will do is it will use the key store, the vault that comes with the M2354 secure MCU. It will use the key store to store the keys. And then the LoRa Mac will leverage the crypto accelerator that's on the device to basically take the sensor data that the machine has gathered and collected with whatever other data, and encrypt that sensor data both with the app key and the network key. Then it will transmit this packet over the LoRaWAN radio, which again comes with the reference design. And then the LoRaWAN gateway will capture this packet. And of course, at this point, then the AWS IoT for LoRaWAN server, which will receive this from the LoRaWAN gateway, will decrypt the packet with the network key and then parcel the packet to the appropriate applications. And of course, in this case, our application, the mobile app application, will use the application key to decrypt and use the data that was captured by the device. So a very easy provisioning experience If you're designing an embedded machine and you want to connect it to the cloud and you want to ensure there's end-to-end security, as I demonstrated in these very easy steps, and of course, once you see the demo itself, this happens very rapidly. I mean, in split seconds. You're requesting keys from the network server. These keys are generated. They're linked to the user. They're sent back to the device. The device stores the keys in a vault in the key store. Then it will use the onboard cryptology, crypto accelerator to encrypt whatever data the machine is collecting with the keys. It will encrypt them, lock them up, and send them over, in this example, a LoRaWAN network back to the cloud. You can use Wi-Fi or any other connectivity mechanism that your machine is designed for. And of course, once the data is decrypted with the application key, in this case, temperature, humidity, and pressure, it's displayed on the mobile app of this reference design. Again, we designed this reference design from the get-go with the intent of providing an excellent out-of-box experience for Nuvoton customers and embedded designers. The firmware, the instruction guides, and everything is readily available. And this reference design is now available for customers to take advantage of. We went a step further, and what we did was we said, look, let's design the firmware that comes with this reference design that does everything I talked about, requesting for the keys and getting the keys back and encrypting the keys. All of the firmware, let's design it with a production quality mentality in mind so that customers can take this as a starting point and integrate it into their own application and build upon it with whatever unique features or whatever unique ways they want to implement it in their design. But the key point is that this is not sample code. This is not example code. It's really quality code that is intended for customers to use as a starting point for their own end design. And by doing this, essentially what we've done is we have removed the barrier to entry for many customers who don't have security designers, who don't have security engineers, who don't have provisioning engineers. We've removed the barrier to entry for those customers. We have reduced the total cost of ownership by developing these apps and by developing this production firmware. And of course, once you use this and focus on what you do best, we will improve your time to market. Additionally, as part of our ecosystem, as part of Nuvoton's ecosystem family of network, we've also partnered with Data.io, who's a global provisioning leader in terms of silicon device programming and provisioning. And what they have done masterfully over the years is IoT security deployment as a service. And their Centrix machine and all the software world that goes along with the Centrix machine essentially delivers a very secure and efficient system for customers to be able to deploy their firmware and data and secrets in both IoT and automotive devices in high volume. So once you have used the Nuvoton reference design to achieve your proof of concept, to validate your design, and you're ready to go to production, we have also partnered with the proper high volume provisioning partner to ensure that you can go to production in a very secure manner. Remember, I started this presentation by talking about the objective is to provide peace of mind for IoT embedded designers and their value chain partners. In fact, once these concepts are deployed in your embedded machines, first and foremost, you will achieve data security. That means you can protect your core assets. So when you encrypt your data and whatever intellectual property you use to achieve or derive intelligence from the data you collect, when you encrypt that with the keys and send it out of your machine, then you're protecting your core assets. And of course, someone cannot hack your machine and steal your core assets. This is like your intellectual property, your customer data, or acquired knowledge over time. Next, you achieve operational security, meaning you and your customers can achieve uninterrupted business operations because your machines are hack-free. And third and foremost, or one of the most important things these days, is brand protection. Once somebody is hacked, then the recovery of the brand and their brand quality takes a long time. So you achieve business security by protecting your brand and your customers' brands. So With all of that said, please do know that the Nuvoton marketing team and engineering team have been actively developing and designing the next generation solution based on the Cortex M33. The reference design I've talked about so far and the device that's been in production is based on the M23. So the next generation is being designed based on the Cortex M33. It's well in development, and of course, it's going to offer enhanced device features, such as improved power consumption and many device-level benefits, as well as solution features specifically targeting enhanced security functionalities so that you can take your designs to the next level of end-to-end security. Thank you very much for listening, and we look forward to you reaching out to get a hold of these reference designs. Thank you.
Thanks, Ali's excellent speech. Now let's enter the next section. Terraria 2, exceptionally low power IoT Wi-Fi, a game changer for IoT 2023. Deepo Mehta, Senior Director, Business Development from Interface.
Good morning, everybody. Good afternoon, good evening, depending on where you are in the world. I'm Deepo Mehta. I'm really honored to be in front of you to share a little bit of our thoughts on sensor to cloud, Wi-Fi connectivity and cloud connectivity for low power sensor applications, IoT applications. My name is Deepo Mehta. I am Senior Director of Business Development at Interface IoT. Interface IoT is a fabless semiconductor company focused on enabling IoT, low power IoT applications. So I'll start by sharing a little bit about my company and the products we do, especially our collaboration with Nuvoton, enabling ultra low power IoT applications for smart home, industrial IoT, and other IoT applications. So Interface IoT is a privately held company, venture backed. We got incorporated in 2022. We are a 100 plus startup company focused on extreme low power, smart wireless solutions for IoT markets. So our key focus has been extreme low power RF radio for Wi-Fi. And we build SoCs and system modules for the wireless IoT marketplace. We focus on Wi-Fi and Bluetooth as a single chip solution, a single chip and a module providing both the multi-protocol wireless solution. And then we work with partners like Nuvoton and ISP vendors to build reference kits, application kits, and an end-to-end solution so that customers can easily develop their IoT applications and deploy it with quick time to market. Our offices, our headquarters are in San Jose, and then we have development centers in San Diego, Sweden, and Bangalore, India. We are very proud to have a very innovative product with 100 plus patents on the RF technology, and then we've taken it a step forward in implementing system level power optimizations and cloud connectivity, which is optimized again for power. And we're proud to be winners of a lot of industry awards and accolades for the work that we've done so far. So the reason we picked Wi-Fi is it's ubiquitous, as you know, right? So Wi-Fi is in laptops, it's in cell phones, but then now in the IoT world, we see a lot of deployment of Wi-Fi enabled IoT devices, which need battery powered devices. So to look at the volumes, multi-billion unit volume for Wi-Fi shipments, and specifically for smart homes, we're seeing a lot of migration to IP-based solutions, where Wi-Fi is definitely one of the key areas that people are focusing on. So we see 50% of connected home devices to be IP-based, and that would be Wi-Fi. So today, if you look at the pain points, there are definitely low power solutions like Bluetooth and Zigbee. But if you look at the throughput requirements of the next generation IoT devices, the firmware upgrade required, the AI enablement of IoT devices, we see the move towards Wi-Fi that would solve a lot of the problems. Again, there's a lot of intermediate gateways required if you're implementing Bluetooth or Zigbee-based IoT devices. But if you are enabling Wi-Fi-based IoT devices, since access point is everywhere, you can get direct cloud connectivity without any intermediate gateway costs. So Wi-Fi definitely is the technology to focus on. And as you go into the future, you will have emerging technologies like Matter for interoperability, which is again based on IP, TCP IP stack, which again, Wi-Fi is the base layer, which would make it happen. So by working on Wi-Fi, we enable, we can realize the promise of IoT. We can get a lot of throughput for advanced use cases like video, lossless audio, and AI-enabled IoT devices. And for low power sensors, you can get a lot, 10 plus year battery life through the solution that we are implementing, which I'll go through, which will pretty much trying to do is having a sensor life equal to the device life, right? So battery life equal to the life of the sensor. So that's kind of the thrust that we're focusing on. In terms of the target applications that we're going for, this shouldn't be any news to people, but smart home, where you have video applications like video cameras, door locks, video doorbells, but also a lot of the smart home appliances, wearables, things like that, that you see in the smart home applications. That's what we focus on. The other key application is industrial IoT. Again, realizing the promise of IoT in the industrial 4.0 world, where you have vibration sensors, humidity sensors, temperature sensors, not only just having the sensors connected to the internet, but also doing AI at the edge, like predictive maintenance, and then asset tracking are some of the use cases that we enable. And then if you go to some of the other emerging use cases are in smart healthcare, where you're doing a lot of patient monitoring and tracking, asset tracking, home use case. There are a lot of pet tracking in terms of tracking the cats or the dogs, as well as in the retail space, monitoring the customers walking in, the traffic, what they are doing, the inventory management on the shelf, things like that. So these are the target applications that we are focused on enabling. So the need of the market is, as I said, there's need to go towards Wi-Fi, but Wi-Fi inherently is very power hungry. So people want Wi-Fi, but they want it at Bluetooth power levels, right? So that's the market problem statement. Bluetooth is low power, but it doesn't have the right protocol stack. It's not migratable towards the Matter protocol and the interoperability required without the gateway cost added, right? So that's one of the requirements. The other one is the direct to cloud connectivity. As I said, you want ease of deployment. So you want IoT sensors, but then you want to be easily deployed without adding gateway boxes to do Bluetooth to Wi-Fi or Zigbee to Wi-Fi or Zigbee to Ethernet kind of connectivity to the internet. And the third thing is they want ease of provisioning and ease of deployment, right? So if you have Wi-Fi, but then if you want to provision the Wi-Fi, you don't want to have wired approach to provision it. So you want Bluetooth or other wireless channel available to provision your Wi-Fi. So what we've done is we've looked at the market needs and come up with a solution which is based on our Teleria platform, which is very low power radio architecture to enable customers to have Wi-Fi Bluetooth power levels and overcome the need for a gateway solution, and then provide an overall cloud connectivity so that they can easily deploy their solutions in the marketplace with rapid time to market. So the products that we offer are the SoCs. These are the basic building blocks that have advanced security features. We have evaluation boards around the SoC, as well as the software stack and the cloud connectivity stack that we have, which is assured and AWS certified. So for customers who can take the SoC, build their RF Wi-Fi solutions around it, they can go that path. There are customers who want quicker time to market. We provide complete integrated modules with the Wi-Fi Bluetooth solution, with the antenna, with the RF BOM around the Wi-Fi Bluetooth SoC, which are globally regulatory certified. So the customers can take the module, put it next to their Nuvoton chip, build a system solution, and quickly deploy their IoT applications for marketplace. So we offer both kind of products depending on the customer choice. They can go either route. So in terms of what's unique and different that we're focusing on, or the value proposition that we bring, is the ultra low power Wi-Fi, right? So as I said, we provide 10 plus years of battery life for sensor to cloud connectivity for low power sensors like occupancy sensors or vibration sensors. But for video camera applications where video is a little bit more power hungry, we still offer 1+ year of battery life, which is 2 to 4x of what you can get in today's solution, which is usually 3 to 6 months only. So we offer the lowest transmit power, which is what the sensor application needs. You want mostly the sensors are transmitting to the cloud, and by having it lower, it's giving you right away the 2x power reduction. But then we also do optimization at the system level, like going into the sleep mode, doing a keep alive with the cloud in a power managed mode, waking up the microcontroller when only it's required, or it can go down to sleep, doing smart scanning. So those are the system level ways of conserving power that we do. There's cost of ownership. So it's not just the cost of the semiconductor or the system solution you get, but it's the provisioning of the software, security that's built into the Nuvoton chip and our chip to combinedly provide a very secured boot and secured firmware updates. And then having an ecosystem that allows you to get the best acquisition cost and interoperability between the various players. And then from the time to market perspective, as I said, we have the modules which are regulatory approved, but then we work with partners like Nuvoton to have a market-ready solution of the MCU plus the Teleria to Wi-Fi Bluetooth solution with the cloud software and the certification, things like that. For video applications, we work with ISPs like Ingenic, Omnivision, Umbrella to have a complete reference design, which is power optimized, and have the solution available for worldwide deployment. If you look at the three quadrants that I mentioned, there are other technologies like Bluetooth and Zigbee that meet that too. But what the Wi-Fi Bluetooth combo solution offers is the scalable features and performance. If you want to go to video, you can do 2K cameras with the same solution. You can enable AI at the edge, which is very important nowadays. So rather than sending all the data to the cloud and letting the cloud do the AI inference, we can, because the battery life is quite long and the Wi-Fi power and the system level power is low, you could add new features like AI right at the device edge. So you could do predictive maintenance at the edge, or you could do object detection at the edge, and which gives you low latency, higher performance IoT applications. And then you can also move to next generation features like Matter, which is very important for smart home applications. So in terms of the go-to-market strategy, as I mentioned, or I can summarize, is we work with partners like Nuvoton to build system-level modules. I'll show some of the examples soon. We build reference designs with a complete SDK integration between the MCU and the Teleria 2. We do it for the low-power applications. We do it for the camera applications, depending on the application that you're looking for. And then we offer a complete certification, be it Wi-Fi, Bluetooth compliance, or global regulatory certification, or Azure or Cloud Stack, Cloud Partner certification, or for that matter, even Matter certification. And then we work with ODMs and OEMs in Taiwan, in China, world over, so that you can get high volume manufacturing options also. So not only you can develop your software, design your product and application, but you can quickly deploy it in high volume to your end customers. So these are some of the building blocks that we have besides the chip and the module. One is the evaluation kit, and I can show you here. So this is the evaluation kit that we have, which is either standalone or Arduino compatible. It can have various antenna options. Either you can use the PCB antenna, you can use external antenna or ceramic antenna. It has built-in sensors like the Bosch pressure sensor, so you can do a sensor to cloud evaluation and application development. We have a quick application stack and a demo applications available, so you can do an end-to-end use case. There's support for AT command set as well as the GCC-based development environment, so that you can do your own application development also. So this evaluation kit is available, so you can check out the performance, you can check out the power, you can see the application fit of this solution to your end needs, and then you can easily get it through worldwide distribution from Mauser and Richardson RFPD. The next one is the one that we worked with Nuvoton. It's a complete low power sensor to cloud reference kit, which uses Nuvoton M252 and the Teleria Wi-Fi Bluetooth solution. It has the support to work with sleepy sensors. So if the data isn't coming all the time, we have a power optimized way of working with sleepy sensors. So waking up when the sensor is about to have the data be transmitted. Once we transmit the data, we go to sleep. We can put the MCU in the sleep mode also. We have connectivity to various kinds of sensors. I've shown some of the sensors here, like the temperature sensor, pressure sensor, PIR sensor. But then there's also a Grow I2C connector for extra scalability for various sensors. This kit comes with an end-to-end software stack with the messaging layer, MQTT to connect to the clouds. It has the security features for application security as well as the TLS security built in. And it gives you a complete Wi-Fi to cloud connectivity, including provisioning the Wi-Fi through Bluetooth with some demo applications. So you can use this as a starting point to build your designs based on Nuvoton plus Teleria Wi-Fi Bluetooth solution. We have another one which is based on more recent Nuvoton M2354 solution. Again, that is paired with our Teleria 2. This is again a ready-to-use reference solution that you can use to connect your sensors through Wi-Fi, through the Nuvoton chip for varied sensor interfaces availability. There's an SDK integration of the Nuvoton software SDK with our Teleria 2 Wi-Fi Bluetooth SDK. End-to-end solution for the cloud that you can start and quickly deploy your solutions. This is another reference kit that we have built. This is again for the video use case. This has the Ingenic T31 video processor or the image signal processor mapped with the Teleria 2 Wi-Fi Bluetooth chip. This is a complete camera reference design, which gives you 1+ year battery life, end-to-end again connectivity to the cloud, and demonstration of the low power. So this again you can use to build your video camera solution. So what we've done is not only provide a 10+ year battery life sensor solutions for low power sensors, but even for higher performance use case like video streaming, up to 2K resolution cameras is what the solution can offer. Again, through noisy environments, the solution is optimized so that you get consistent performance, good quality video image, and is integrated with the ISP's Linux host environment. So again, end-to-end solution, which meets need of most of the video camera requirements that you may have. And this is a little bit more in detail, but this is how we get the 1+ year battery life in the power optimized video application, that we have a dual stack approach. The Teleria 2 Wi-Fi Bluetooth solution has an integrated ARM controller where we can offload the TCP IP stack as well as the cloud connectivity stack running on Teleria 2. So in the camera use case, when most of the time the PIR sensor doesn't have any activity that they're showing, the Teleria 2 maintains the cloud connectivity using the integrated ARM controller, while the power hungry ISP is totally powered down. When the PIR sensor wakes up, if there's some detection, then the Teleria 2 will wake up the ISP, and then it will do the object detection. If it's a false alert, again, it will go back to sleep. If it's a real human detection or something that needs to be recorded, then they'll stream it and then again go back to sleep. So we've got this end-to-end solution working with multiple ISPs like Ingenic, Omnivision, Umbrella, to allow you to have a 1+ year battery life solution. Again, software SDK integration with the cloud stack, connectivity to Amazon, connectivity to Microsoft Azure, or the cloud of your choice through the standard messaging layer. This shows the end-to-end connectivity software that we have. So from all the way from the sensor on the left side, talking to the Teleria to Wi-Fi Bluetooth solution, you could use either the GPIOs and the ADCs in Teleria 2, or you can work with Nuaton's extensive peripheral interface to get the sensor input. But the Teleria 2 maintains the cloud connectivity, the TCP IP stack connecting to the cloud. On the cloud side, you can have a cloud software. We do have demo software, but that's where you have the command and control. That's where you manage the devices, the monitor devices, do the firmware updates. All that happens on the cloud side, while Teleria 2 maintains the IoT level application software and connectivity through secured mechanisms using Nuaton chips and our chip together. So again, having an end-to-end solution allows you to build your end applications much faster and deploy to the marketplace. This again shows a little bit of the software architecture. You could use Teleria 2 in a self-hosted mode if you have limited I/O needs of talking to the sensor by using the integrated ARM controller in the Teleria 2. But in the most cases, you could pair up with a MCU like a Nuaton M252 or a Nuaton 2354. There's a complete software SDK integration of how the Nuaton chip talks to the Teleria 2, either through the AT command set or through the Happy interface that we built, which makes it very easy, a C library, which is very portable from one Nuaton platform to another. So again, with the RTOS and end-to-end solution, that's possible. And same way for camera applications, we have Linux embedded host Linux platform integrated with the Teleria 2 SDK. This kind of shows a little bit more in detail the software stack. So the lower portion is the one in the orange is the hardware with the integrated ARM controller with the crypto accelerators for security and the coprocessors for doing the Wi-Fi Bluetooth function. On the top of it is the software stack that where we run the TCP IP stack, the storage interfaces, the security interfaces, but also the messaging layer of talking to the cloud. And then on top of that, any user application. The user application could either run on Teleria 2 or it could run on the host, as we'll see in the next diagram. This is the software diagram view of how the end-to-end system works, where the host application could run on the MCU, talk to the Teleria 2 using the UART, SPA, or SDIO interface, whichever way is your choice, either through the Happy interface or through the AT command set. And so this end-to-end SDK solution is available to you as a starting point using some of the platforms that I mentioned earlier, the reference kits. So the use of this solution has enabled us to have customers in a broad variety of market segments, the target segments that I started the presentation with. So battery-powered cameras for home security or video doorbells, video cameras, or maybe retail space, any camera application or image capturing application is where you want the Wi-Fi connectivity, the high throughput, and the cloud connectivity to stream the video recorded or the image captured to the cloud. And then in the smart home applications, we have publicly mentioned Sansa blind controller as an application where you have a blind controller with Wi-Fi built in using our solution, directly connecting to the Amazon cloud and to an Android app where you could control the functions of the blind. And there are other applications like smart garage door openers or smart buttons that can be used in the smart home space. And then in the industrial IoT space, with customers doing machine monitoring, vibration sensing, boiler control, asset tracking, a lot of the applications. So we not only have the reference solutions working with partners like Nuvoton, but then we have customers who are either in production or close to production. And we look forward to working with a lot of the other customers who have interest, and together with Nuvoton, we can meet the needs in any of the segments. So I'll summarize this by saying, the time has come to cut the cord, have battery-powered, Wi-Fi-based wireless IoT applications with significant battery life, 10 plus years battery life. So essentially, you don't need to worry about changing the batteries for IoT applications. Make it very easy to use, easy to deploy. You can get the performance of Wi-Fi for the emerging applications. You have ease of cloud connectivity, which is what people need today, either through your Android apps or through the cloud services. Have your IoT applications end-to-end working and deployed. And more importantly, doing it quickly, right? You don't want to wait 12 to 18 months to develop your application, deploy. You want to be able to do in 3 to 6 months. So that's what we are focused on. That's what we are excited about. And that's what we look forward to working with you in the future. Thank you very much for the opportunity, and appreciate your time and look forward to working with you. Thank you.
Hello, everyone. This is Robert Lin from Nuvoton Microcontroller Application Business Group. I'm very honored here to introduce you our IoT security solutions by MCU and NPU, as well as our latest security technologies. In the beginning, let's address common IoT security threats. Firstly, it's unsafe communication, unauthorized access, like remote access, private information leaks, home invasions. How do we protect the connection? We can adopt secure socket layer SSL, TLS protocols, digital certificates, symmetric and asymmetric key systems for authentication. Then security features of an MCU will need secure storage for unique ID, certificates, keys, unpredictable random number generator, cryptographic accelerator. Here is a simple figure to illustrate an IoT device goes through gateway network to cloud service. When data transmitting in the channel, it will face eavesdropping, spoofing, tampering with data, and local device may get injecting malicious codes from network, tampering with data, even entire firmware leakage to get cloning device. Secondly, it's compromised IoT devices like botnet attack, malware attack. How do we authorize the embedded firmware image and the firmware update? Then security features of an MCU will cover secure boot and secure OTA, secure storage for certificates, keys, signature, cryptographic accelerators, trust zone isolation to limit access, OTP for lifecycle management. Thirdly, it's a physical attack. Physical tampering like a JTAG interface access, clock and voltage pins, glitches. Then security features of an MCU will cover physical tampering detection, protected flash memory inside of an MCU, trust zone isolation to limit access can help, clock pin monitoring and voltage pin glitch detection. After discussion the IoT security threats, we can set up the MCU security target depending on attack types on MCU. Here we categorize the 3 levels: invasive hardware attacks, non-invasive hardware attacks, software attacks. For the top level invasive hardware attacks like covering microprobing, FIB, focused ion beam. So these attacks need to be conducted in a very special environment like a laboratory. So these attacks may be targeting payment related applications for a secure chip. For non-invasive hardware attacks and software attacks, we believe the IoT application, medical application, and other general MCU applications will also need the security features in the future. Here we listed currently progress of IoT security related certifications. This slide will help you to understand how to integrate sufficient security features to defend against the software attacks and the non-invasive hardware attacks. Here we listed the CC, CSIP, PSA, CSPN, IEC 62443, and the layer levels for matching software attacks, non-invasive hardware attacks, and invasive hardware attacks. In particularly, we want to address CSIP and PSA. These two standards are getting popular for IoT applications. Here is a summary for numerical IoT security technology summary. In overall, we have 4 categories: MCU system security, crypto security, product lifecycle security, and the software and service. With MCU system security, we have a secure boot, device identification, isolation. This covers trust zone M, trust zone A, flash memory protection, system anti-tampering, chip level security. For crypto security, we have our homemade TRNG hardware accelerators for different cryptographic acceleration, secure storage, product lifecycle security covering product lifecycle management mechanism. We also incorporate debug interface security into our product lifecycle security. We provide a lot of security reference software for your implementation, the security functions easily. We can also provide provision service, including key certificate, even firmware. Now let's jump into our numerical M235X security MCU product. We developed the MCU security features by our first generation M2351 covering M261, M262, M263. We started from secure boot, key generation, secure boot of root of trust, anti-clone, secure debug, and the secure connectivity with embed RTOS, SSL, TOX, DTLS libraries, FOTA firmware over the air update, product lifecycle management. Then we develop the secure storage, highly secure storage assurance features also for cryptographic side channel attack, differential power analysis attack mitigation, fault injection mitigation. Here is a more deep discussion for our M235X IoT security microcontroller. In the age of M2351, it's our first Cortex M23 based trust zone CPU and CPU based MCU. We integrated the trust zone CPU and the software, also cryptographic hardware, PCB level tampering mitigation countermeasure with our M2351. So it's a software root of trust. When we got a lot of feedback from our customers and the market, we realized the secure key store importance. So we enhanced our secure key store, surrounded by reduced EM signals, chip label tampering for key store, secure key provision service, also the data scramble mechanism inside of MCU. So with this very complete security mechanism, we have confidence M2354 can be hardware root of trust solution for IoT ecosystem. This slide emphasizes our M2354 IoT platform with TFM. TFM is mainly promoted by MCU industry, especially from for ARM-based MCU. With the trusted firmware M architecture, customer can easily to develop a program software on the trust zone architecture. Pneumaton provide very complete IoT platform by M2354 with trusted firmware M libraries for developers, customers to easily develop different IoT applications with a different connectivity, like different radio frequency driver, radio frequency module, different RTOS vendors, cloud vendors, and the application root of trust, PSA root of trust are provided by our trusted firmware M libraries. Except the very complete security features, our M2354 series also have outstanding power performance. Here we listed the power mode and the wake up time respectively. So basically our M2354, like M2351 also, we can provide two kinds of power supply through LDO and DC-DC. You can check the power performance with our full speed 96 megahertz in normal run mode, idle mode, fast wake up power down mode, normal power down mode, standard power down mode, and the deep power down mode. This slide shows our supporting for multiple real-time operating system. The multiple real-time operating system support can speed up your RTOS porting if you do need operating system ready on your device to save your OS porting time. Here we listed the IP connectivity ready status, covering Wi-Fi module, NB-IoT reference module, and 802.14.4 covering Thread and ZigBee. Also for LoRa, non-IP connectivity. For RTOS, we now support Embed OS, FreeRTOS, and RT-Thread. We also have several cloud system connectivity evaluation done, like covering ARM Palladium, Amazon AWS IoT, and Microsoft Azure IoT Hub. Here, I'm happy to introduce our advanced security features for cybersecurity, especially for IoT gateway, IIoT, industrial IoT gateway. The MA certified D1 is a trusted system for IoT products security requirements. It can It can realize execution security, communication security, chip level storage security, system security for gateway devices. So there are dual Cortex A35 cores inside of the NPU. And there is a real-time monitor Cortex M4 CPU. Also, the TSI, Trusted Secure Island, covering all the security features, functions. The secure environment and feature realize the protection, detection, and recovery for IoT products. In particularly, the TSI is an isolated secure hardware unit. The built-in cryptographic accelerators, key store, and OTP flash memory. All the features can perform all the security function operations, including secure boot and tamper pins detection. Here is a Pneumaton security technology roadmap summary. With this slide, you can see our MCU and the NPU products can help you to against the software attacks and the lightware hardware attacks, as well as provide a secure boot and trusted execution environment. We also monitoring the new industrial requirements to develop a new mechanism to meet the new future security standards. So we started from M0, M4 series with the basic memory protection unit, cryptographic accelerator, PRNG, unique ID, flash memory protection mechanism, CRC tamper pins. And these, you can see the functions with our existing M0, M4 products to against the software attacks. With M40, M480 series, we develop secure boot, OTP memory, and our M2351, the first trust ARM-VAM-based MCU. We put trust zone, SOM, for secure boot and the trust execution environment. So M2351 is eligible to get the PSA level 2 certified. When entering M2354, we enhanced our secure boot trust zone design with our secure key store, as I explained previously, more OTP flash memory. Then we have a very complete product life cycle management, covering life cycle control, debug point management, also the photo injection and cryptographic side channel attack protections. So we are confident M2354 can get PSA level 3 certified soon. In the future, for the vertical market, we will monitoring the latest security standards developed by different industries. So our next MCU or NPU product for IoT security, we will develop unified secure boot covering bootloader, crypto key store, flash memory controller. Also for external flash or external storage security, we will have on-chip, on-the-fly AES decryption, flash write protection. And our crypto hardware will keep enhancing to protect the feed against the more complex side channel attacks and the full injection attacks. Thanks for your time to listen me the introduction. And it's very welcome of you to go on our official website to get more our IoT security related product information.